According to the National Electrical Code, or NEC, 2 AWG copper wire is indeed sufficient for a 125 amp breaker. The NEC specifies the ampacity, or current carrying capacity, of 2 AWG copper wire as 125 amps. Therefore, downgrading the breaker to 100 amps is not required. The existing 125 amp breaker is appropriately sized for the 2 AWG wire based on its ampacity rating and the load connected to the sub-panel. While upgrading the 2 AWG wire to a thicker gauge wire while keeping the 125 amp breaker is permissible, it is not a necessity, as the current wiring is already adequate for the load. The NEC stipulates that the sub-panel should have an amperage rating equal to or greater than the breaker that feeds it. In this scenario, the sub-panel should ideally be rated for at least 125 amps. It is highly recommended to seek advice from a qualified electrician to guarantee the safety and code compliance of the electrical system. In summary, the present wiring and breaker arrangement meet NEC standards and are deemed safe based on the details provided. Hence, making changes to the electrical system is unnecessary at this moment. To elaborate on the specifics, let's delve into how the National Electrical Code, or NEC, addresses wire ampacity and breaker sizing. Firstly, the NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and installation conditions. For 2 AWG copper wire with common insulation types like THHN or THWN, the ampacity is typically listed as 125 amps when installed in raceways or direct buried. This is assuming an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit and not more than 3 current carrying conductors in a raceway or cable. Secondly, the purpose of a circuit breaker is to protect the wire from overcurrent. The breaker should be sized to trip before the wire's ampacity is exceeded, preventing overheating and potential fire hazards. In this case, the 125 amp breaker is designed to trip if the current exceeds 125 amps, thereby protecting the 2 AWG wire, which is rated for 125 amps. Thirdly, concerning the sub-panel rating, the NEC requires that the sub-panel be rated for at least the size of the feeder breaker. If the sub-panel is rated lower than 125 amps, it could become a point of failure. It is crucial to verify the sub-panel's rating to ensure it matches or exceeds the 125 amp breaker. Now, let's consider the connected loads to the sub-panel, as provided earlier, which includes a 3.5-ton central air conditioner, a stove or range, a tankless water heater, an air conditioning wall unit or refrigerator, a dishwasher, a microwave range hood combo, 2 small kitchen appliance circuits, and 7 general lighting and receptacle circuits. Calculating the total load involves several steps. 1. Determine the continuous and non-continuous loads. Continuous loads are those expected to operate for 3 hours or more at a time. 2. Apply a demand factor to non-continuous loads, as not all loads will operate simultaneously at their maximum capacity. 3. Sum up all the loads, applying the appropriate demand factors to determine the total calculated load. This calculation will determine whether the 125 amp breaker is sufficient for the sub-panel's load. It is essential to consider the starting current of motors, such as the air conditioner and refrigerator, as they draw significantly more current upon startup. The NEC allows for oversizing breakers to accommodate motor starting currents while still providing overcurrent protection for the wires. The NEC Section 210.22 addresses branch circuit load calculations, while Article 220 covers feeder and service load calculations. These sections provide detailed guidelines for calculating the load on a panel. In the specific case mentioned earlier, the 2 AWG copper wire is adequate for the 125 amp breaker, and downgrading the breaker is not necessary based on the provided information. Upgrading the wire gauge is also unnecessary, as the current wiring meets the NEC requirements. However, it is still imperative to confirm the sub-panel's rating and perform a comprehensive load calculation to ensure the entire system is safe and code compliant. It's always a good idea to consult with a licensed electrician to perform these calculations accurately and address any specific concerns. When considering electrical work, it's helpful to understand some fundamental electrical concepts. Firstly, voltage is the electrical potential difference that drives current through a circuit measured in volts. Common residential voltages are 120 volts for lighting and small appliances and 240 volts for larger appliances like stoves and air conditioners. Secondly, current is the flow of electrical charge measured in amps. The amount of current drawn by an appliance depends on its power rating and voltage. Thirdly, resistance is the opposition to the flow of current measured in ohms. The resistance of a wire depends on its material, length, and cross-sectional area. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is crucial in understanding how electrical circuits behave. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It is updated every 3 years to reflect the latest safety practices and technological advancements. The NEC covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. Local jurisdictions often adopt the NEC with amendments to suit local conditions. Compliance with the NEC is essential to ensure the safety of electrical installations. Electrical permits and inspections are typically required for new installations and modifications to existing systems. These processes help to verify that the work is performed by qualified individuals and complies with the NEC. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding of metallic parts. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by detecting small imbalances in current. They are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or RFCs, are devices that protect against fires caused by arcing faults. They are typically required in bedrooms and other living areas. Wiring methods refer to the types of cables and conduits used to run electrical wiring. Common wiring methods include non-metallic sheath cable, or ROMIX, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. Each wiring method has its own advantages and disadvantages in terms of cost, ease of installation, and protection against physical damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds their rating. Fuses are one-time devices that melt and interrupt the circuit when the current exceeds their rating. Electrical boxes are enclosures used to protect wiring connections and provide a mounting point for devices such as switches and receptacles. Electrical boxes are available in various sizes and materials to suit different applications. When working with electrical systems, it is essential to follow safe work practices. Always turn off the power at the breaker before working on any electrical circuit. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Regarding the specific situation with the 2 AWG wire and 125 amp breaker, it's crucial to verify that all connections are properly torqued to the manufacturer's specifications. Loose connections can cause overheating and arcing, which can lead to fires. Regularly inspect the electrical panel for signs of corrosion, damage, or loose connections. If any issues are found, have them addressed promptly by a qualified electrician. The lifespan of electrical components varies depending on their quality, usage, and environmental conditions. Circuit breakers typically last for many years, but they can fail over time. It's a good practice to test circuit breakers periodically to ensure they are functioning properly. Replacement of the components in the electrical panel after a certain period of time may be a good decision. In conclusion, While the 2 AWG wire is rated for 125 amps and the breaker is appropriately sized, it's essential to consider the entire electrical system safety and compliance. A thorough load calculation, verification of the sub-panel's rating, and regular inspections are crucial to ensure the system operates safely and efficiently. Always consult with a qualified electrician for any electrical work to ensure it's done correctly and in accordance with the NEC. Additional considerations include ensuring proper ventilation around the electrical panel to prevent overheating. Also, avoid overloading circuits by plugging too many devices into a single outlet. Using surge protectors can help protect sensitive electronic equipment from voltage spikes. If you plan to add new circuits or appliances, consult with an electrician to ensure the electrical system can handle the additional load. It's essential to keep the electrical panel accessible and free from obstructions. Don't store flammable materials near the electrical panel. If you notice any unusual smells, sounds, or smoke coming from the electrical panel, turn off the power immediately and call an electrician. The National Electrical Code, or NEC, is a living document that is constantly evolving to address new technologies and safety concerns. Staying up to date with the latest NEC requirements is essential for anyone working with electrical systems. Continuing education and training are crucial for electricians to maintain their skills and knowledge. Many organizations offer electrical training programs and certifications. Hiring a licensed and insured electrician is essential to ensure that the work is performed by a qualified professional and that you are protected from liability in case of accidents. Always ask for references and check the electrician's credentials before hiring them. Obtaining multiple bids from different electricians can help you get the best price for the work. Be sure to compare the bids carefully and ask questions about any differences. When evaluating electrical work, it's essential to consider not only the cost but also the quality of the materials and workmanship. Cheaper is not always better, as substandard work can lead to safety hazards and costly repairs in the future. In conclusion, while the initial assessment suggests that the 2 AWG wire and 125 amp breaker are compliant with the NEC, a comprehensive evaluation of the entire electrical system is crucial to ensure safety and reliability. Consulting with a qualified electrician is always recommended to address any specific concerns and ensure that the work is done correctly and safely. Remember that electrical safety is paramount, and it's always better to err on the side of caution when dealing with electricity.